We want to find the area of the quadrilateral that has sides of length 4.8 meters, 7.2 meters, 9.2 meters, and 12.6 meters, and the angle between the two smallest sides is 107 degrees. So looking at the quadrilateral, notice how A and B are the two smallest sides or shortest sides, and therefore this angle here measures 107 degrees. To find the area of this quadrilateral, we'll divide it up into two triangles, find the area of each triangle, and then find the sum of the two areas. So let's divide this so that one triangle has an angle that measures 107 degrees. Let's go ahead and divide the quadrilateral here. So we'll first find the area of this triangle, which we'll call area A sub 1, and then we'll find the area of the second triangle, which we'll call area A sub 2. There are a couple of ways to do this. To find the area of this first triangle, we'll use the area formula area equals 1/2 AB sine C. Remember, the relationship here is that angle C is the included angle, or the angle formed by side A and B. Then we'll use the law of cosines to find the length of this side here, and then to find the area of the second triangle A sub 2, we'll actually use Heron's formula given here, where the area is equal to the square root of this product, where S is the semi-perimeter, or half of the perimeter of the triangle. Let's begin by finding the area of the green triangle, or A sub 1. A sub 1 is equal to 1/2, or 0.5, times, again, A and B are the two sides that form the known angle, and therefore we'll have 1/2 times 4.8 times 7.2 times sine 107 degrees. And now we'll go to the calculator. Let's first verify that we are in degree mode. So we'll press the mode key. We are in degree mode. So we'll go back to the home screen. We'll enter 1/2 or 0.5 times 4.8 times 7.2 times sine 107 degrees. So A sub 1 is approximately 16.5249 square meters. Now we'll work on determining the area of A sub 2. And notice how to apply Heron's formula. You do have to have the length of all three sides. So we're missing the length of this side here. Let's call it x. But we can find the length of this missing side by using this upper triangle in green, using the law of cosines. The law of cosines is a squared equals b squared plus c squared minus 2bc cosine a. So the important thing to recognize here is that the known angle is angle A, and the side opposite the known angle would be side A. So to find x using the law of cosines, we would say x squared equals b squared plus c squared. These are the two sides that form the known angle, so it would be 4.8 squared plus 7.2 squared, and then minus 2 times 4.8 times 7.2 times cosine of the angle opposite side x, or the known angle of 107 degrees. Now we'll go back to the calculator. So we have x squared equals 4.8 squared, right arrow, plus 7.2 squared, right arrow, minus 2 times 4.8 times 7.2 times cosine 107 degrees. So this gives us x squared is approximately 95.0887. We know x has to be positive, so now we'll take the principal square root of both sides. So for the square root, we press second x squared, and then we have 95.0887. So x is approximately 9.7513. Now at this point we are going to use Heron's formula, but what we could do is use a law of cosines to find one angle in this orange triangle, and then use the formula area equals 1/2 AB sine C again to find the second area. But we are going to use Heron's formula since we do have the length of all three sides. Let's go ahead and do this on the next slide. To apply Heron's formula, we'll begin by determining the semi-perimeter, or S, where S is equal to 1/2 times the sum of the three sides. So we'd have 9.7513 plus 9.2 plus 12.6. To say sometime I've already found this value, this is an approximate value because this is a rounded value here, so we should use an approximation sign here as well. This comes out to approximately 15.7757. So using Heron's formula, a sub 2 is approximately equal to the square root of s, 15.7757, times the quantity s minus a, times the quantity s minus b, times the quantity s minus c, where again a, b, and c are the lengths of the three sides. I've already determined these differences to save some time. And now we'll go back to the calculator. We have the square root of 15.7757 times 6.0244 times 6.5757 times 3.1757. So the area of this orange triangle is approximately 44.5494 square meters. So now that we have the approximate area of the orange triangle and the approximate value of the green triangle, we can find the sum to approximate the area of the quadrilateral. The total area of the quadrilateral would be approximately equal to, again, a sub 1 plus a sub 2, which would be 16.5249 plus 44.5494. So the total area would be approximately, if you round to two decimal places, the area would be approximately 61.07 square meters. I hope you found this helpful.